Resistor color code system, there are 4th, 5th, and 6th band resistor color codes. This table provides information on how to read the 4th, 5th, and 6th band resistor color code. So you need the chart to know exactly what every color and band positions mean. Check out the materials only available in our channel for data on resistor color codes, letter codes, numeric codes, and EIA 96 code system. If you want to know the resistance value of a resistor from the color code, first check out how many color bands are marked on the body of the resistor. If there are 4, you make reference to the color code chart with the 4th band tolerance. If the bands are 5, make reference to the chart with the 5th band tolerance. If the bands are 6, make reference to the chart with the 6th band temperature coefficient. So for this resistor, there are 4 color bands, so I'm making reference to this particular chart because there are 4 color bands marked on the body of this resistor. And the second thing, where do you start the reading from? Some instructors will tell you to start the reading from the band closer to the end of the resistor and not far away from the end of the resistor, like in this case. The reading starts here. In this case too, this band is far away from the end, the reading starts here. But most important thing you should check out for is the tolerance band. The tolerance band are of 2 colors, gold or silver. So you don't start your reading from the tolerance band, you start your reading from either of these band marked on the resistor. Some cases, like the 5th band, you don't also start your reading from the multiplier band or the tolerance band. You do so from the 1st band. The tolerance band will always carry 2 colors. Remember, gold and silver. The multiplier band can carry any of these colors except to represent the tolerance band. The reading. We choose this resistor for our first reading. The color bands, first band is red, second same is red, third band, the multiplier band now is black, and the 4th band, the tolerance is gold. Okay, I come over again. We are working with a resistor with 4 color bands. That is why we are making reference to the 4th band tolerance chart. The first band is red. And what is the value of red in the chart? The value of red with reference to the first band marked here is 2. The second band same is red, and the value of red with reference to the second band is 2. That we have 22. That is our first 2 digits. The third band, usually called the multiplier band, is black, and we locate black here, making reference to not the first, not the second, but the multiplier, because we're working now with the third band, the multiplier band. The multiplier represents the power of 10. In this chart, the power of 10 is simplified. For example, the power of 10 for 1 is the same as 10 raised to the power of 0. You can say exponential 0. The power of 10 for this digit is 10 raised to the power of 1. That is why we have 1 0 digits. The power of 10 for this times 100 ohms is 10 raised to the power of 2. That is why 2 zeros appear here. The power of 10 for 1 kilo ohms is 10 raised to the power of 3 ohms. Remember, kilo represents 10 to power 3. That is 1000. Mega represents 10 to power 6. That is 1 million. Refer to the previous module where we carefully explained this mathematical concept. Back to the reading. Still on the third band, black. Third band, black. The value of black is 10 raised to the power of 0, which is the same as 1. So the resistance value of this resistor with the color bands red, 2, second band red, second band, the multiplier black, which is times 1, is 22 times 1 ohm. Do not forget the last band, which represents the tolerance of the resistor. The last band is gold, and our value for the fourth band is ohms. 22 times 1 equals 22. 22 times 1 ohm equals 22 ohms, plus or minus 5% tolerance. Plus or minus 5% tolerance means the actual resistance of this resistor can vary anywhere between 22 minus 5 ohms and 22 plus 5 ohms. That is to say, the resistance of this 22 ohms resistor with a plus or minus 5% tolerance can vary between 17 ohms and 27 ohms, anywhere between those values, and that gives you its operating resistance range. In practice, if this resistor gets bad, you can represent a resistor with the resistance within its range if the same resistor cannot be found. It is important to consider the tolerance of resistors, especially in circuits that are sensitive to changes in resistance. Let's identify the resistance value of this resistor. The first band is brown. The second is gray. The multiplier band is orange and the tolerance band is gold. The first color band, brown, with reference to the chart is 1. Second color band, gray, with reference to the chart, second is 8. So you have 1 and 8, 18. And the third multiplier is orange. Orange to the multiplier, we have times 1000 ohms, or you can call 1 kilo ohms, and that is 18 times 1 kilo ohms equals 18 kilo ohms. So this resistor is a 18 kilo ohms resistor with tolerance band color gold, plus or minus 5% tolerance. The final resistance value reaches 18 kilo ohms plus or minus 5% tolerance. We have a 5 color band resistor. The first band blue, the second band gray, the third band, not the multiplier this time, black. The multiplier, which is the fourth band, is gold, and the fifth band is black, representing the tolerance band. With reference to the charts, blue, the first band, the value is 6 with reference to the first band. The second band here, with reference to the chart, gray, with reference to the second band in the chart is 8. The value is 8. So that is 6, 8. Take note. The third band, black. Since black is the absence of colors, black is normally considered to be 0 at any band position. Black is considered to be 0. White, on the other hand, is the combination of all colors and is considered the highest value, 9. Black 0, white 9. Back to the reading. Gold, which is the fourth band, represent the multiplier. Here is times 0.1. So the resistance value reads 680 times 0.1 ohms. That is 680 times 0.1 ohms equals 68.0 ohms. To understand how decimal points are calculated in mathematics, check out the material in the channel. This resistor will give the resistance of 68.0 ohms, and since black has 0 tolerance, the final resistance is 68 ohms. 4 and 5 band colors are the ones you see the most. The 6 band color is much more rare. 6th band represents the temperature coefficient of the resistor. ppm per Kelvin is an abbreviation for parts per million per degree Kelvin. The 6th band indicates how much the resistance of the resistor changes with temperature. Resistor A, which is the resistor with a higher temperature coefficient, will likely cause a more significant shift in the circuit behavior as temperature rises. The output voltage could deviate from its intended value as temperature rises. Resistor B with a lower temperature coefficient will be less sensitive to temperature change. The higher or lower temperature coefficient does not mean the resistance falls or increases. It means the resistance can be positive, the resistance can be negative or zero, just the fluctuation. For a resistor with a higher temperature coefficient indicated by its seized band is likely to be unstable as temperature rises in the circuit than resistors with a lower temperature coefficient, also indicated in the seized band. Depending on the specific requirements of your circuit, if stability and precision is critical, a lower temperature coefficient might be a good choice.